This is the Professor Dr. Dolphy Gilpin, and we have just produced now the amazing 10x12 matrix with its specialized chemistry application in science. So we have S for science in the STEM, but specifically chemistry. At other times we have focus on mathematics, sometimes on economics, sometimes on sport. Right now we're focusing on everything together, and so we call it multi-field or multi-dimensional. We are doing everything all together here. Multi-dimensional application, multi-field. So here we are. So we have now and that will be to Am10 multiplied by N, where N is a number 1 to 100. And since we start off at 10, it will be like from 11 to 100 here, and starting off at 11. Like I said, no, we are on a multi-dimensional or multi-field application here, and so we are clustering many fields: STEM, science, S for sport, S for science, T for teaching, E for economics, E for engineering, M for music, maths, medicine, and everything is being clustered here. So, multi-field, multi-dimensional. And we start off at 11 here. And we have STEM. We also have STEAM and STREAM. Most visible would be the economic application here, and the sport application here. The science is the chemistry that we have just finished. So let's start off continuing from 11. And so we have A, B, C, A, 11-1, A, 11-2, A, 11-3, A, 11-4, A, 11-5, A, 11-6, A, 11-7, A11H and B. So I'm making some abridgment here. And we have now DEF, A12-1, A12-2, A12-3, A12-4, A12-5, A12-6, A12-7, A12-8, and we have an E. Let's see how far we'll take it tonight. Multidimensional, multi-field application. GHI A131, A132, A133, A134, A135, A136, A137, A138, JKL A141, A142, A143, A144, A145, A146, A147, A148, space there. MNO A151, A152, A153, A154, A155, A156, A157, A158, so we have 16 here now. P, Q, and R. A, 16-1, A 16-2. So 18 now. V, W, and X. A 18-1, A 18-2, A 18-3, A 18-4, A 18-5, A 18-6, A 18-7, A 18-8. notice that we didn't even mention about the 5x12 there, but those are markers, but the 5x12 was integrated in the specialized chemistry matrix there. 5x12, 10x12. The 10x12 complete the 120 element. If we want to go by the 5x12, they would have only gotten half of the periodic table, or the relative of the periodic table, or the number of elements of the periodic table. So we would have only gone to neodymium, which is 60. So we have specialized markers, 5x12, 10x12, 15x12, 27x12 coming up, which is the sunflower matrix. So we'll take a break of the sunflower matrix, or before. So we have A22-1, A22-2, A22-3, A22-4, A22-5, A22-6, A22-7, A22-8, and that's I prime. I'll use dash. The dash means we are exercising first order differentiation there, and usually we ended up with a lot of differentiation here to the 10th, 11th, and 12th order differentiation when we reach out to the central matrix. But let's see what we will accomplish tonight. KLM, take it day by day, night by night. 23. A23-1, A23-2, A23-3, A23-4, A23-5, A23-6, A23-7, A23-8, L prime. 24. Nope. NOP, nope. First order. N dash, O dash, P dash. Differentiating first time. We definitely exercise, as you know, these differentiation with Newtonian calculus differentiation and anti-derivatives or anti-differentiation. Okay, so here we have NOP, A24-1, A24-2, A24-3, A24-4, A24-5, A24-6, A24-7, A24-8, and then O prime here. 25, Q, S, A25-1, A25-2, A25-3. And we are going to conclude this session here with the sunflower matrix, the 27x12. And so we're stopping at the 27x12 here. W, X, and Y. And so we have A27-1, A27-2, A27-3, A27-4, A27-5, A27-6, A27-7, and A27-8. And we have an X prime here, and we will continue with this, and we put it here, the sunflower matrix here, the sunflower matrix, the 27 by 12. So let's just highlight this, and we'll take a break for the night. So here we started off from the 11th, continuing from the AMZ 10 by 12 specialized chemistry matrix. So we took it up from 11 here, and we are saying we are going into a multi-dimensional, multi-field application in which a lot of fields are integrated into one, so it makes it a little bit cumbersome to decipher or differentiate. Moreover, we have some differentiation or dash product here that will be exercised, and we have done marker 15 and marker 27, which is the sunflower matrix, and here we have taken a break at the sunflower matrix. And there's no need to introduce the sunflower matrix. Those who want to know of the background of the sunflower matrix should check upon my other generation or production in the matrix, amazing matrices series. So there it is.